Welcome to Ants Are Everywhere. We're taking a round two look at Deepseek. In the first round, we honestly didn't really get very far. We played around with Deepseek a little bit, and hang on. And we looked a little bit at the code. At the time, I hadn't looked very closely or really at all at the Deepseek V2, V3, or R1 papers. I had looked at the original paper. I had some time yesterday to look at the R1 paper, but my kid got sick, and my kid is homesick, so I may get interrupted here. But my take on the R1 paper is there's not a lot that's really actionable in terms of understanding what the code is doing. I don't see where they've released any of the code for R1. The code is all in Deepseek V3, and my feeling is that until I really read the V2 and V3 papers, which I will do tonight, the architectural differences that we see in the V3 code base won't be so clear to me. So we may look at the V3 code base a little bit more today, but I thought it would be good to start off with the R1 paper. We haven't looked much at academic papers on the show. I don't really have a format for how to read through them, and sight reading in academic papers may be even less informative than sight reading a source repo. But I've at least taken a little bit of a look at it, so I'm not entirely going in blind. So let's see if we can pull up this paper. I don't know the fastest way to get there, but we can try this. I'll just Deepseek R1 PDF. I don't think I have it bookmarked on this browser. This seems to be the PDF. And let's make sure this is going. Oh, I know what I did. I see the issue I created for myself. Okay. All right, so here's the PDF. I do not want it in this preview mode. Ideally, I would just be able to open this. Okay. And this is nice and bright and white. What are the chances that I can make it inverse image? Here we go. Okay, so it's a pretty short paper, about 20 pages, the last like 4 of which are maybe appendices, or no. Yeah, close to that. So we have references and then appendices. Again, for those who are not super familiar with the show, I have a math background. I don't have an AI or machine learning background. So I'm getting up to date with all of this stuff. There are probably many people in the tech community who are more up to date on AI and LLMs and the mathematics behind them. So I'm not taking a rigorous view, and I'm not going to understand all the things that are going on. I'll give you my sense of what's going on, and then if people are able to chime in with tidbits that I'm not aware of or anything else that might help, then that would be useful. Okay. So the main thing that they do here in the R1, the reinforcement learning paper, is they're going to they have an existing model, which I believe is Deepseek V3. And they're going to add the capability of reasoning to that model, where reasoning means that they want the model to essentially generate tokens that capture the kind of like inner monologue thinking process behind coming up with an answer. And the idea is that it's been shown experimentally that when models do that, they provide better answers. And in particular, this sort of reasoning process seems to be especially useful on things like academic benchmarks, doing mathematics, answering exam questions. And so that's a lot of what we see presented here. I don't know exactly what all of these benchmarks are. Math 500, I assume, is some math test. MMLU might also be a math test. SWE is presumably software engineering. And I believe AIME is also math. Code Forces is probably something like elite code programs. Not programs, what's the word? Problems. And I don't know what GPQA is. Is it worth looking these up? Maybe it is. Let's look up. How about GPQA? And AIME. Is that what it was? A performance evaluation framework. Something about multiple GPUs. I'm not sure if that's the thing. So GPQA is biology, physics, and chemistry. That is, so like graduate level Google Proof Q&A. Google Proof. I'm guessing Google Proof means difficult to Google. So maybe I'll read this paper at a later time. Okay, so where's my PDF here? All right, so and on the inverted colors, at least, the yellow hatched on the left-hand side here is the performance of Deepseek R1. The barely visible, kind of darker brown on the right side is Deepseek V3. And the kind of in the middle, we have OpenAI and OpenAI Mini. And we see that Deepseek R1 kind of just edges out OpenAI on a bunch of these benchmarks. It just misses OpenAI on Code Forces. It just surpasses on AIME. Does a little bit worse on GPQA. It does appreciably better, I guess I would say, on Math 500, and so on and so forth. So the performance is really close to OpenAI 01 1217. I don't know if 1217 is a date. I don't know how this is named, but they're really close to 01 performance. In an open source model, that's really pretty remarkable. OpenAI 01 Mini also does really well on all of these things. And Deepseek V3, you can see, is not doing well on a lot of the benchmarks. The performance from 01 Mini falls off on a few of these benchmarks. And everything, I assume, we don't have error bars, but I would assume we're all pretty close to that. A lot of these fall in the same confidence intervals. I'm not sure that these are statistically significant. Maybe they are if you collect enough data, but that's sort of what I see here. I do want to know what Math 500 is now, though. It's some mathematical reasoning benchmark. I just want to know what's in it. Data set? Okay. A subset of 500 problems from the math benchmark that OpenAI created for Let's Verify Step-by-Step paper. So it's some data set that's some competition math problems. Now, like I mentioned before, there's been some speculation that Deepseek isn't being completely honest. I don't know how to assess any of those claims. There's certainly been a history of what you might call like corporate espionage, where US results make their way over to China. There's a Chinese company created to encompass them, and then and they do very well. For example, you get like Chinese billionaires that come from results taken from US universities. It possibly, I don't know, happens the other way, where Americans take results from not people, but the ideas developed within China, within their university system. And I think even Google was like predated by like a Chinese search engine that did some similar things. Google Chinese search engine paper. Maybe PageRank. Is this it? No, this is 2001. I'm not sure. So I'm not sure I'm remembering that correctly about algorithms that predated PageRank. So Kleinberg, I know. University of Padua. I don't think that's Italy, right? Anyway, I think there's a paper from a Chinese university, maybe like a year or two ahead of PageRank, that's very similar. I don't know if that means that we stole it from China or what, but there is this history of ideas going back and forth. And so some people, I think, just think possibly based on that history, possibly based on something technical in these papers that I don't see that there's some sort of something going on. I have no way of evaluating any of those claims. I don't have a position on them. Certainly without any evidence, it's possible. Who knows? But it does seem, one question I guess I do have is that now, since all these benchmarks are public, if you are willing to be slightly dishonest, you can just train to the benchmark. And I don't know how that is that's handled. That can happen from a U.S. company. That can happen from a company in any country. If they want to show that they're doing well on a benchmark, they can slip in some competition math problems in the training set or whatever, and it'll do well on the benchmark. Presumably that wouldn't generalize well, but if your goal is to show that you have benchmark supremacy, that's something that you can do. And so for that reason, I don't know how much emphasis to put on the benchmarks in terms of understanding the contribution that they've made. And then in terms of what the like research theoretical contribution is, they do kind of two things. And I think this is discussed in the introduction here. Let's maybe look at the table of contents. Yeah, okay, so they have Deepseek R10 and Deepseek R1. And the way they describe it, the contribution of Deepseek R10 is that they're doing reinforcement learning on the base model, a model that hasn't been trained with supervised learning to do reasoning like things. And they talk about how this is interesting because nobody has done this publicly before. And they observed some interesting results, like the model learned how to like essentially go back and check its thinking. And then they say essentially that the Deepseek R10 model doesn't produce readable results, and it like mixes up languages in a way that's unwelcome to the user. And so they like abandon Deepseek R10. They release it, but it's not what they end up using. And then for Deepseek R1, they do what other people have done. They do some supervised training to get the model to understand essentially the format of reasoning that they're supposed to do. And then they do the same kind of reinforcement learning training from R10. So that's, to me, that's a little bit strange because the model that ends up being good is the model that uses the same, a similar setup to other reasoning models, if I'm understanding it correctly, which I'm. I apologize, I'm still getting over a cold. So it seems like the model, the R1 model, not the R10 model that ends up performing really well, is trained in a more similar way to other reasoning models. And so the main contribution, the way that they describe it, this R10 model is something that ends up getting thrown away, more or less. They do some useful experiments, and they talk about like failures and false starts. All of that stuff is great. This paper is extremely readable, as I mentioned on the Discord. before the last stream, all of these papers are really readable. They're I consider them remarkably readable for AI papers. So all of that is a wonderful contribution on its own. And so then the question is, like, how are they going to train this with reinforcement learning? And that's discussed in this section. And then here they talk about how they're going to first do some supervised learning and then use reinforcement learning. And they have some stuff about rejection sampling. I'm not sure exactly how they go about doing that. And then they talk more about how they reinforce stuff. I think that one of the theories, I don't know if we want to call it a conspiracy theory, but one of the theories for how they might have cheated, if they cheated, is by using, if I'm understanding this theory correctly, using output from OpenAI as part of the reinforcement process. Again, I don't know anything about that. I don't know if any of those theories are correct. But personally, if I didn't have a legal requirement not to use OpenAI, I feel like that I would at least consider that as something to do, because we'd get a head start. I would think that if you believe that AI has implications for humanity as a whole, and whether they thrive or don't thrive, I don't see why you wouldn't use every tool at your disposal. But maybe I'm less restrained or less ethical than other people. Okay, so the R10, they talk about how they do. I forget what this paragraph is doing. Let me take a quick look at it. Yeah, okay. They're just saying that without any supervised data and focusing on self-evolution through a pure reinforcement learning process. And they describe the algorithm here. They call it group relative policy optimization. And they cite this Xiao et al. Paper, which I think is a Deepseek paper. Let me just check this. Deepseek math. Yeah, so I don't know if this is a standard. This kind of looked like a standard thing to me, but I don't know reinforcement learning that well. But basically, it seems like they are sampling a policy. It forgoes the critic model. I assume the critic model is the taking an actor-critic approach. My understanding was that the use of actor-critic was not generally thought to be good for this application. So I'm not sure exactly what they mean by saying they forgo the critic model. I think that's standard, but I'm not sure, which is typically the same size as the policy model. So the critic model uses a lot of parameters, same as the policy model. And so they don't do that. So it saves by not using that many parameters. And it estimates the baseline from group scores instead. So for each question, Q, so little q is a question. They're going to sample a group of outputs, O1 to OG, from the old policy. I'm guessing maybe Q is something like a prompt, and they're going to, perhaps with different random seeds, generate the model outputs from the prompt. I don't know how this sampling of a group of outputs works. And then they're going to optimize a policy model, pi of sub theta, by maximizing the following objective. So they're going to maximize some expectation. And when I read this the first time, I missed the fact that there's no equal sign here. I thought this was defining the expectation. But I'm not sure, is this supposed to be multiplying? Is there something going wrong when I've inverted colors? Let me switch back to white. Yeah, I'm not sure how to read this, but maybe I'll ask ChatGPT. But here we have some expectation. The expectation of Q, which is distributed as P of Q. I'm guessing P is, we're just supposed to assume is some probability distribution. I don't think they say. And we have the OI from I to uppercase G. I guess G is the size of the output set. And these outputs are distributed according to the old policy, pi of theta old, evaluated on O, I'm not sure what O is given Q. O is maybe the outputs. I don't know. And then we've got this thing, which is we're going to divide by G, essentially, presumably to scale or normalize, and sum over the big G outputs of a thing. And that thing is, we're going to take the minimum of some stuff, and we're going to subtract off the Kullback-Leibler divergence of pi theta from pi ref. And I'm not really sure what pi ref is, but this seems to be just the definition of the divergence, the DKL. And this minimum is a minimum between, we're going to take the ratio of pi theta, which is the thing that we're trying to estimate, of all of the outputs given Q, divided by the old policy. So pi theta is the new policy we're trying to find. Pi theta old is the old policy that the outputs were generated in reference to. And we're going to multiply that by AI, which we get a definition here. This is the advantage. We'll look at that in a second. And we're going to take the minimum of that and this clippy thing, where we're clipping, it looks like the same ratio between 1 minus theta and 1 plus theta, I guess, to keep it presumably close to the unit interval, and multiplying that by the AIs, and then like subtracting off the divergence here. And epsilon and beta are hyperparameters, so you get to choose your favorite values and try different training scenarios and seeing which ones work best. And AI is the advantage, computed using a group of rewards, R1 to RG corresponding to the outputs within each group. So we're going to take AI. It's going to be reward I minus the mean of the rewards of all the rewards corresponding to these outputs, I guess, and dividing by their standard deviation. So this is essentially taking the rewards and centering them at zero, and giving them unit standard deviation. So it's just a uniformization, it looks like. And here's the prompt, or rather the template. So it says that you're going to do a conversation between user and agent. It says that you're going to put your think stuff between the thinky tags, and then you're going to put your answer between the answery tags. And then this prompt, which is here in teal, is going to be replaced from question to question. And then they have this assistant colon thing, and the model will fill out the rest of the prompt stuff by sampling. So that's that. What it doesn't really tell us, though, and I think this is the big question, is like, what are the rewards? And we get a little bit of that here. Reward modeling. So the reward is the source of the training signal, which decides the optimization direction of RL. So what does this mean? So essentially this says, essentially what this says is you're going to do your homework, and we're going to give you a score on your homework. And based on that score on your homework, you're going to get better somehow. You're going to decide, like, if you get a D minus, you're going to try a bunch of things. And if one of those things gives you a D plus, you'll start doing that thing more, and so on. And so that kind of tells you how you get better, what's important to you. It doesn't tell you like how we're going to grade you. And the reward modeling is kind of like how we're going to grade you. And it says there's two kinds of rewards they talk about. There's accuracy rewards. The accuracy reward model evaluates whether the response is correct. So for something like mathematics, this is, you could imagine this is relatively easy to do. A lot of homework these days, even in like math and calculus, is done on like a website where you have to put in your answer, and it has to be like exactly the right format, and the computer can grade it. And so this is, I assume, something like computer grading. For example, in the case of math problems with deterministic results, the model is required to provide the final answer in a specified format, for example, within a box, enabling reliable rule-based verification of correctness. So that sounds to me like just computer grading of like assignments. Similarly, for lead code problems, a compiler can be used to generate feedback based on predefined test cases. So they're just going to run the automated tests just like in a CS course. And then we have format. Although, how you're going to do this at scale, I don't really know. But an interview that I read with the Deepseek guy said essentially they have unlimited amounts of money. I assume that they can just pay people to set this up for them. Format rewards. In addition to the accuracy reward model, we employ a format reward model that enforces the model to put its thinking process between these two thinking tokens. So that makes sense. So you reward putting stuff in the thinking tokens. It seems like they're not, they're certainly not using supervised training to train it to use the thinking tokens. I assume that at the beginning, at least, there were lots of attempts to do thinking where you might get the format wrong, or you might put the slash on the wrong side, or you might misspell think. And it just learned over time to use those tokens is I think more or less what it's saying. The thing that jumps out to me as being a little bit unusual is this mainly. So we don't really know what the real reinforcement, what the real rewards are, because these are it's mainly using these two types of rewards. And so there's a lot of slack there that you could reward it to never use the letter E, and that would produce a different sort of model than if you rewarded it to always use the letter E an even number of times, for example. And then they say they don't apply the outcome or process neural reward model. And I don't know what outcome or process neural rewards are. Maybe we can ask them. Oh, now. Where's my... Something's fishy with the... There we go. Okay. So what are outcome and process neural rewards? So it says they're used by the brain or artificial neural networks. So outcome rewards are given after the completion of an action based on the final result. For example, it receives a high reward after executing a successful trading strategy in reinforcement learning. And then process are intrinsic rewards given during the execution of an action. A reinforcement learning agent receives a reward for exploring new trading strategies even before seeing the final results, for example. Okay, so it seems like the rewards they talk about are outcome rewards, but I assume that may be like a special definition in AI that these maybe don't count as outcome rewards. I'm not sure. And then they talk about designing a straightforward template that guides the base model to adhere to our specified instructions. It requires Deepseek R10 to first produce a reasoning process, followed by the final answer. And then other than having this template, which is the thing I think is that we looked it up here, table 1, yeah. They don't really, this is really the only constraint. They don't require you to think in a certain way. And then they talk about evaluating the performance, and it seems to do pretty well. Here's a little bit better than O1 Mini for some of the 4is, but at any rate, either better or almost as good as O1, and it seems to be generally better than O1 Mini. At least in some of these, assuming higher is better. I don't know. And then they talk about this aha moment. Where is this? A particularly intriguing phenomenon observed during the training of R10 is the occurrence of an aha moment. This moment, as illustrated in Table 3, occurs in an intermediate version of the model. During this phase, Deepseek R10 learns to allocate more thinking time to a problem by re-evaluating its initial approach. This behavior is not only a testament to the model's growing reasoning abilities, but also a captivating example of how reinforcement learning can lead to unexpected and sophisticated outcomes. So where's table 3? And so here, I assume that this is maybe added by the researchers, but it tries to solve this equation and rearranges, and then it says, let's reevaluate this step by step to identify the correct sum, and so on. And so, I mean, that is interesting. You do see that in Deepseek. I don't know if Deepseek is live and let's say, tell me a joke about two pirates that enter a tavern and both are wearing exactly the same outfit. But you'll find that it like thinks about things and then backtracks and says like, oh, wait a minute, maybe I need to think about this or that. And I'm not sure it's going to work. Yesterday, it seemed to be either overloaded or DDoSed. We'll give you some time to think. And then so they talk somewhere, I guess I'm not going to really find it, about how it's not so user-friendly. And their question is, can we improve the functioning by incorporating a small amount of high-quality data as a cold start? And how can we train a user-friendly model that not only produces clear and coherent chains of thought, but also demonstrates strong general capabilities? So they have these problems that I mentioned at the beginning of the video, essentially the multiple languages. Hey, Friction. It produces multiple languages, presumably like English and Chinese mixed. I know a lot of their, wait a minute. I know a lot of their training examples are in Chinese because they show that in some of the appendixes. But there may also be other languages, and they don't like having it go back and forth because that's confusing to the reader. So those are the main things that they talk about. Yeah, readability and potential. Okay, great. And so, did I miss a major? Yeah, okay. So now this is Deepseek R1. We're getting rid of R10. I'm going to move you aside real quick, this chat. And for this, they are going to do what's the word? Supervised training. They keep calling it cold start. I feel like the supervised training warms up the start, so you're not doing a cold start, but I guess that's maybe just what it's called. So they explored a few examples, which they talk about here. And then what they end up doing is they collect thousands of cold start data to fine-tune the Deepseek v3 base as a starting port for RL. So again, in the R10, they said the main contribution was that they were training the base model without any of this like fine-tuning beforehand. Now they're saying that we're going to fine-tune and we're going to collect thousands of data and then run the same reinforcement learning process that they did on R10, and it's going to make it more readable and stuff. And they don't really tell you where they get the data. But after fine-tuning, they apply the same large-scale model, and they invoke, and the reinforcement learning focuses on enhancing the model's reasoning capabilities, particularly with reasoning-intensive tasks such as coding, mathematics, science, etc. They observe that there's often language mixing, and to mitigate this, they add a language consistency reward during training, which is the proportion of target language words in the chain of thought. So if your chain of thought is like 100% English words as opposed to 70% English words, the 100% English words chain of thought gets a higher reward, and so the model moves in that direction. And they say that when they test this reward using an ablation study, which is basically they test with and without the reward, that requiring the same language results in slightly degraded performance against, I don't know, maybe benchmarks, against some sort of benchmark, but humans prefer it. So there's like some sort of implicit human benchmark that it's doing better at, so they leave it in. And then when the reasoning learning RL converges, they're doing some rejection sampling. The resulting checkpoint, so they take this thing is checkpointing probably like every 5 minutes or so. they're going to take the supervised fine-tuning data. Okay, so they're going to take this checkpoint and use it, I guess, to generate data to fine-tune the next round. By, they call it rejection sampling. I think they're just basically generating a bunch of results and throwing away the bad ones. Unlike the initial cold start data, which primarily focuses on reasoning, this stage incorporates data from other domains to enhance the model's capabilities in writing, role-playing, and other general-purpose tasks. So it sounds a little bit like they're just taking the best examples produced by the model and using that to fine-tune. We curate reasoning prompts and generate reasoning trajectories by performing rejection sampling from the checkpoint from the above RL training. In the previous stage, we only included data that could be evaluated using rule-based rewards. So that's, I think, things like, does it compile? Is your math problem correct? However, in this stage, we expand the dataset by incorporating additional data, some of which use a generative reward model. I'm not sure what a generative reward model is, by feeding the ground truth and model predictions into Deepseek v3 for judgment. Okay, so the model predicts some stuff. There is some ground truth. I don't know how they decide what the ground truth is, but I guess V3 is the judge. Additionally, because the model output is sometimes chaotic and difficult to read, we have filtered out chain of thought with mixed languages, long paragraphs, etc. So they filter out ones they don't like. Logic is better in multilingual token. Isn't OpenAI accusing DeepSeek of distillation of GPT? Hello. Hello, everybody. I don't know. They may be. I think I've seen that some people have raised the distillation of GPT as a possibility. Is OpenAI like publicly accusing? I don't know. Oh, I don't get the Thinky tokens here. Is that something I can turn on? Okay, so here's my pirate joke. Two pirates walk into a tavern, both wearing the same outfit, same hat, same coat, even the same eye patch. The bartender says, well, what's with the matching outfits? And the first pirate grumbles, we've got the same buccaneer. That's not it. That's not how that, no. Let's see. I'm going to click the DeepThink R1 and see if it's going to produce a different. Okay, so there's some thinking. Okay, and here's what it looks like. Okay, the user wants another joke about two pirates with the same outfit. Let me recall the previous interaction. Last time they used the pun buccaneer. They probably want something similar but different. I do not want something similar. I need to ensure this joke isn't a repeat. Let's brainstorm pirate-related terms. Parrot, peg, like. I mean, this is really cool. I don't know what the reasoning looks like in O1. Alternative, ahoy there, could be a pun. Let's think, and so on and so forth. And so it's like, going back. Alternatively, wait, Jolly Roger. It's like saying that it remembers things, and it's going through different examples. I stole this joke idea, I think, from a Hacker News comment that did a similar joke. I knew that this would kick off a reasoning process that would not be too controversial or anything. Let's see if we can see this advanced reasoning ones. I'll say, let's do a new one. Wait, what? This one. So tell me a joke. I'll just copy the same prompt. DeepSeek is still thinking. I don't remember if O1 gives me access to the reasoning tokens. Crafting humor. And then I will look up if there's any sort of public accusation. Ekshunya, when you say logic is better in multilingual token, thanks, Friction. Ekshunya, are you saying that is this a generally known thing, or are you summarizing what they say in the paper, which is that when they get rid of the multilingual token, the ablation studies show that there's a slight hit? All right, so they thought about this joke. It says, two identical pirates walk into a tavern wearing the exact same outfit. The barkeep squints at them and growls, ye two look like perfect copies. One pirate shrugs and replies, aye, that's piracy. Okay, that's not terrible. And then AI says, It says, crafting humor. I'm building a joke around two pirates wearing matching outfits entering a tavern. The bartender makes a pun about their identical attire and parrots, leading to a playful twist. Revisiting humor. I'm refining the joke with simpler puns like pirates, choosing matching outfits to take advantage of a tavern special on doubles, adding to a lighthearted twist to their attire choices. So this, to me, the details look like they may have generated something similar to what we get with Deepseek, but they're feeding this then into another process that summarizes it, so you don't have to like watch the person think, or perhaps to just hide what the underlying process looks like, so that other AI companies like Google or Meta / Facebook can't copy what they're doing. So my guess is that if OpenAI is accusing them, my guess is they know what the underlying thinking process looks like. We don't, and that this is a deliberate summarization, passing it presumably into the same model, or maybe they trained something else to do the summarizing of the thinking. But I'm guessing that's part of what's going on. And let's see if we can just look up if OpenAI is like publicly accusing. OpenAI accuses Deepseek. I don't know, news? Okay, yeah, so Sam Altman has, I don't know if that's the same. Sam Altman's OpenAI said Chinese competitor Deepseek could be committing intellectual property theft. And it could have used distillation. We'll say this to Wallabag. It expressed concern Wednesday that, okay, and so on. It's possible. So they're certainly saying they think it's happening. They're being they're being cagey. I assume they're being cagey for legal reasons, and also possibly not wanting to start more of a international conflict reasons. And so I have no idea of evaluating that. But let's go on to distillation. We can, I think, go by the rest of this pretty quickly. They have some non-reasoning data. For simpler queries such as hello, we do not provide a chain of thought in response. In the end, we collected a total of approximately 200,000 training examples that are unrelated to reasoning. So they have other things maybe that don't require a chain of thought. They have different data, and they have a bunch of data for different scenarios. This is where what you might call the censoring comes in. All models are to some extent censored. I think that, frankly, one of the reasons OpenAI beat Google to the punch is that they figured out a way of nerfing their model better than the private model that Google had at the time. Microsoft had only a few years before, I think, released a Twitter AI chat model that was pretty good, but Twitter got it to say super racist things. And I think that Google, being a huge multinational company, was reluctant to really go far out on a limb to release their model, and OpenAI, as an upstart, had more leeway and figured out a way to, you might say, censor it, make sure it doesn't say harmful things. And so that would be, I think, part of this process, which they generally call alignment. They train the model using a combination of reward signals and diverse prompt distributions. Somewhere, we resort to reward models to capture human preferences in complex and nuanced scenarios. So resort to reward models sounds like they prefer not to do that, but basically they're saying that there are some places where humans have concerns about harmlessness and helpfulness, like, for example, not being racist. And they take human feedback on their responses and update them. And I think that's the same thing that OpenAI did. I read some very long paper with a huge appendix about it. I don't remember if that paper was from OpenAI or from maybe from Microsoft or something, and for helpfulness and harmlessness. And I'm guessing that if the model was trained to promote socialist core values, this is where that would have taken place. Also, I think Deepseek is working on an open source image diffusion one. That's cool. I feel like I'm a big fan of the open source models. And, you know, I'm not entirely opposed to the piracy. So I say good for them. Yeah, okay. Ablation study says performance drops when reasoning tokens are restricted to multilingual. There's some guy about some OpenAI being used in China with heavy usage. Huh. Yeah. Oh, I see what you're saying. You're saying that about some OpenAI API being used in China with heavy usage. So I assume by heavy usage you mean like not just heavy personal usage, but like, and not just heavy corporate usage, but like noticeable on the logs. Someone in China is using like way more of the OpenAI API than everyone else, and maybe the implication is that they suspect that that usage of the OpenAI API was to distill a model, namely the Deepseek model. And it makes human sense as well. Some ideas might be better embedded in different languages. Yeah, I think that's true. I would bet. I'm not entirely surprised that thinking in different languages can give you better results. I think that, like, for example, in the, like, say, 70s and 80s, I mean, we can go further back. There, you know, for example, academic results aren't always translated into different languages. So back in the day, if you spoke French and English, you had access to more mathematical research than someone who just spoke English did. And if you trained a model and the knowledge in the different languages was different, and you're able to switch back and forth between the languages during the reasoning process, I could imagine that giving you access to better information and better reasoning, just because you have kind of more places that you can go to in the abstract space that you're working through. I frankly, you know, if you're OpenAI and you're going to do the summarization, then maybe you don't care about language consistency. And so maybe that's one advantage of doing the summarization. And I guess you care less about readability in general. Maybe the computer can make up its own LLM language that like some version of LLM Pig Latin that humans can't understand. And that's part of the reasoning process. And maybe that's another reason to kind of like summarize the reasoning process rather than giving the user the raw output. But I have a hard stop in 15 minutes about at 9:30. And so I want to look at distillation. I'd expected to look at some of the code today. We're not going to do that. We'll look more at the code tomorrow. And I'll read the V3 paper before then, maybe the V2 if I have time to read them both. I assume that there is a V3 paper. I'm not 100% sure on that. Okay. So in distillation, this I did think was super interesting. The main result I got from it was that they tried to apply the reinforcement learning magic goo to teach smaller models to reason. And that produced like significantly worse results than taking the big model that had already learned how to reason and having it tutor the small models how to reason, which kind of makes sense if you think about humans. It's often, if you want to learn physics, it's often better to find a great physicist to tutor you than it is for you to try to like go through the same steps that they had learned to learn physics. In this metaphor, you as a person with less experience have like a smaller brain, have fewer parameters. That's obviously not true literally in terms of like, you know, brain connections, but I think figuratively that kind of makes sense why it's better to have this, why it's better to distill from a small model than to learn reasoning from the small model directly. But basically what they're doing, I think, is generating reasoning examples from the big model and using them to fine tune the small models. And let's see if they say literally that. To equip more efficient, smaller models with reasoning capabilities like Deepseek R1, we directly fine-tuned open source models like Kenn. I don't really know what Kenn is. And Llama. Kenn is some 2024 citation. Llama, I guess, also has a 2024 citation, using 800,000 samples curated with Deepseek R1, as detailed in section 2.3.3. So that's a section we've already looked at. So I think they generated the samples, made a bunch, and then they asked R1 which ones were the best. Our findings indicate that straightforward distillation method significantly enhances the reasoning capabilities of smaller models. The base models we use here are Kenn 2.5 Math 1.5b, Math 7b, etc., etc. We select Llama 3.3 because its reasoning capability is slightly better than that of Llama 3.1. For a distilled model, we apply only supervised fine-tuning and do not include a reinforcement learning stage, even though incorporating reinforcement learning could substantially boost model performance. Our primary goal here is to demonstrate the effectiveness of the distillation technique, leaving the exploration of RL to the broader research community. And then they just really talk about their evaluation stuff. So, I'm missing a bunch of linguistic, they have a really cool Engshenya. Kenn is the Alibaba model. Okay. Can you imagine a 1.5 billion? Yeah, it's really incredible. Against benchmarks, I think we don't know. We don't know where it's bad, right? So if you're fine tuning toward a given benchmark, that might produce something that's like catastrophically bad at something, and we don't know until we've deployed it everywhere. So I don't know how you would even figure that out. But if you have fewer parameters to play with, then it's possible that as you're teaching it to reason well, it's unlearning something else. I don't really know. It's bad at conversation and good at logic. Oh, okay. Is that true? It has a prompting suggestion in the paper. It's in this paper? Do you mean for the distilled models? So it has this evaluation prompt stuff. I'm going to mostly ignore the evaluation, just in the interest of time. And because, again, I feel like benchmarks are the sort of thing that, like, if you really want to do well on a benchmark, you can do well on a benchmark in ways that are not, that don't necessarily produce like general good results. So I don't want to look too closely. This unsuccessful attempts, I think, was pretty interesting. I'm not going to look too closely at it. I do want to talk about the question of like whether they distilled. What makes this a little bit unusual to me as an academic paper is they have this first study, which is like, look, we can do reinforcement learning, and it learns how to think, but it's not great. So the thing we did is we probably shouldn't do, and we'll go back to the supervised fine tuning. And then they talk about supervised fine tuning, and they say like, well, we're going to start with, we're going to use the thing we did here to like bootstrap, and then we're going to train in iterations where we've learned a little bit of reasoning, and we'll use those reasoning tokens to train to fine tune the next round and so on. And then they say like, oh, by the way, you can just take a larger model that already knows how to reason, and supervised fine tuning is enough to teach it how to reason well. And so kind of taken together, it seems like it seems if distillation is enough for small models, then distillation from ChatGPT to Deepseek should be enough for Deepseek. And there's kind of like enough ambiguity and wiggle room in the way that they've written things up where it seems like you could just take reasoning outputs from ChatGPT, do supervised fine training on them to produce Deepseek R1, and you do that just a little bit. And then once you have that little bit of what they call cold start data, then you can use Deepseek R1 to like continue training itself, since it's learned how to kind of do that particular trick from ChatGPT. So I would say like it seems possible. The thing that they're accusing them of seems kind of like consistent with how they've done the paper. I don't have any sense of whether that's actually what they did. I kind of prefer to err on the side of trusting people. So I think that's where I stand now. And I'm not frankly a huge fan, not frankly a huge fan of OpenAI anyway. So I don't know. But it is cool. I think we have more information here in Deepseek than we had from OpenAI. It's produced a public model. I guess I have a question of what we know about I don't know what OpenAI has published with respect to learning how to reason. Here's some announcement. We're introducing OpenAI O1, a new large language model. And they talk about some of the results. Here's some evaluations, which this is all old news. And they say the O1 is trained with reinforcement learning to perform complex reasoning. O1 thinks before it can answer. You can use O1. I don't know if there's a paper. Here's a comparative study on reasoning patterns of OpenAI's O1 model. And it looks like this is from October 2024. These are certainly lots of Asian names. I don't know where these folks are from. University of Manchester, OpenAI team, Abaka AI, Zhejiang University, University of Chinese Academy of Sciences. I mean, so there is some study with some OpenAI people and some Chinese universities that I think predates the R1 paper that's like looking into how O1 does reasoning. I mean, so it's possible. The OpenAI claims are possible. Universities are often a way. Universities are often, sometimes, occasionally work with the governments of the countries that they are in. Who knows? I guess we'll learn more. But it seems good if we can get some like uncensored versions that we have that we have these powerful things. You're seeing a lot of stuff on like Hacker News of people taking kind of the smallified versions of Deepseek and putting them in on devices that you wouldn't ordinarily be able to run a model on. For stuff like that, like if you're using embedded devices, one would hope that there are no like catastrophically bad blind spots in these models. Like you wouldn't want like an embedded security device that was like easily fooled by by like a wig and glasses or like a fake nose or something. You'd want to make sure that you aren't losing something that's going to create a big hole in whatever you're trying to build. I don't know how you would even begin to do that this early in the game. I'm assuming people are working on those sorts of things. Yeah, Deepseek is more open than OpenAI. After testing Deepseek, I'm pretty sure they just stole Llama. They did, after closing out the model, I had to restart to get the, could be nefarious good. They did say in the first paper that they based their original architecture on Llama. I feel like if they I feel like if they had started with llama, they would have just said so. But again, I don't know. And what else? We've got 5 minutes. What should we do for 5 minutes? I don't think I can meaningfully get anything from the code for 5 minutes. I don't know if there's like 5 minutes worth of like a new topic I can start on this paper. There was somebody said something about there's like prompting guidelines. So Josie thinks that you think that they stole Llama 2 as opposed to OpenAI. Let's ask Deepseek for prompting guidelines. Give me some tips for prompting Deepseek R1. And I'll ask ChatGPT the same thing and see if they have like similar prompting styles. Is 5A the appendix? Let's go. Where did my table of contents go? I closed it, didn't I? Side panel. Five A, section 5. Let's go to the top. Oh, in the conclusion section, blah, 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 general capabilities, language mixing, prompt engineering, evaluated in the limitation section. Okay. Where's limitations? Yeah. So I'm seeing, here's some stuff about prompting. It is sensitive to prompts. Few-shot prompting consistently degrades its performance. Therefore, we recommend users directly describe the problem and specify an output format using a zero-shot setting for optimal results. Okay, I see. The distilled model seems to be running super well on my machine, but I don't know. I don't know really how to compare it to other models. I haven't used Ollama for many other models, so I'm not sure how to compare that yet. Start with background information. If you have a specific topic, GPT will let them know up front. Provide relevant details and constraints. For example, if you need a response at a certain reading level. Okay, state that explicitly. Ask direct questions. Use clear, direct languages. Avoid ambiguity. Instead of tell me about science, try explain how photosynthesis works in simple terms. And be specific about your goals. Use role player perspectives. Assign a role if it helps. Okay. And then you can iterate and refine. Break down complex prompts. Leverage the system and user prompt structure if available. Set the overall style, tone, and constraints for your conversation. You can ask specific, et cetera, et cetera. Okay, so these are all good. I bet these are pretty similar. Specify the output format is the same. Iterate and refine is like almost literally the same. Leverage role playing is almost literally the same. Breakdown, this is exactly the same. Okay, be specific and direct. Is this literally the same? Set the context, ask direct questions, avoid vague questions, provide context. I mean, these are almost the same responses. Let's try asking no, let's try asking Deepseek a deliberately bad math question. So prove the following. For any set x1, x2, ... xn of integers with n congruent to 4 mod 7, show that x contains an even number, which is obviously not true. I'm just curious to see what it will do with this. Yeah, you can check their website for name sizes of the LLMs that they were trained on. Okay. I think that I think Olama is just maybe running faster and more stably than what I was using before. I don't know if that's because Olama is more efficient, or if it has to do with the format, or what. Okay, so Deepseek is having trouble, but I do need to go. So that's Deepseek round 2 for now. For round 3, I'll read the Deepseek V3 paper and V2 paper, assuming those are both things, and try to get a handle on the actual architectural differences of V3. Today we looked at the reinforcement learning stuff that was used to teach it how to think, but there wasn't really any like code relevant stuff that would show up, for example, in the V3 inference code, because there weren't any real architectural changes. It was just about training, and the training and infrastructure stuff is not public as far as I know at this point. So I'll see you guys tomorrow.